Hey everyone, this is Mike Wolf, your host for today's virtual event, From Sourdough to the End of Meat, a conversation about fermentation and food tech. Sudeep and I were having a little bit of conversation. It seems like we're having a little bit of AV issues between he and I, so we're going to just deal with it and roll with the punches. If you guys are having issues, just let us know in the social sidebar. But we're just going to get rolling. I'm excited to have Sudeep with us today. He's the program director and biological engineer at Ginkgo Bioworks. And we're going to have an hour-long conversation about the power of biotech and how new approaches to age-old processes like fermentation are changing the way we think about the future and helping us to create a new food future. Real quickly, here's the structure of today's event. We will be having a quick presentation by Sudeep. He'll go over about 10,000 years of food tech history in 10 minutes, no pressure. And then we're going to have a conversation and I'll ask some questions. And then we'll open up to the audience. And so that's really it. Sudeep, if you want to bring up your screen. Can you hear me now, Sudeep?
Geez, I think it's frozen for me.
Okay. Let me ask people in the audience, am I frozen or is Sudeep frozen?
Refresh.
Okay, he's going to hit refresh. Like I said, we're having a bit of AV issues this morning, if you guys can hear me.
All right, back.
Hey, no problem. So Sudeep, I just gave a quick intro. If you want to bring up your presentation and then just get going, Sudeep's going to give a quick presentation and then I'll just kind of step into the background and then that'll set the context for our question and answer period and then also questions from the audience.
Just making sure people can see my
I can see your screen. We're going to make that large and we'll get going.
Fantastic. And Mike, you have my number. If I'm frozen up or anything, just give me a text.
Exactly. I will do.
First of all, thank you so much for having me. I'm really excited to be talking about this thing that I love, and talking about this technology that we have in our hands and that we're able to play around with. I wanted to start talking about food in general and food technology that we have and that we've been playing around with for quite some time. And I personally have problems with time and have problems thinking about time. So I've represented time on this graph in the log scale, starting with today and 6 months ago, and going all the way back 500,000 years. And I want to make the point that 500,000 years is nothing in terms of the context. So the yeast that we're cultivating at home, the yeast that we love and drink beer with and drink wine with and is involved in chocolate, that developed hundreds of millions years ago. So this entire timeline that I'm showing you could have happened, 1,000 times over or 500 times over. And that's sort of the scale that we're discussing in this talk. Just to give some sense of what's going on in this timeline, I've put in some things to help you keep track of where we are in human history. So about between 200 to 300 Homo sapiens are emerging out of Africa. That's all the way on the left. And that's a very long time ago. And if there's a lot that happens, and this is a controversial timeline because they've made some decisions as to what to represent. But the next big thing, which to give you some context, is the Lascaux cave paintings and the development of art and culture, and how that's sort of impinging on humans and what humans are creating. After 5,000 years, again, a lot of things have happened. But to give you some perspective, the Bronze Age collapse happens about 3,000 years ago, and this is where we get the big Greek epics and really the beginning of the Western canon of literature. This is the Iliad, the Odyssey. This is where we have Exodus and the foundations of the Bible coming up during this Bronze Age collapse. The Roman Empire is the next big thing, and I realize there's a lot that happens between the Bronze Age collapse and the Roman Empire, but this is a log scale, and you can only fit so many things onto there. And the Roman Empire lasts for a very, very long time. Then you get to sort of the age of science. And again, I realize people are going to yell at me for saying not much happens between the Roman Empire and Galileo, but I wanted to emphasize the fact that we enter into this age of science with physics, with Galileo and Isaac Newton, and then at the beginning of the 20th century, we have the Haber-Bosch process, which is a way of fixing nitrogen into the soil and making sure that we have nitrogen to use as fertilizer. 50 years ago, this past July, was the moon landing. After that, on this timeline, we can think about the internet being developed and the iPhone being released. And now, unfortunately, we're sort of stuck at home due to the SARS-CoV pandemic, which is going on in the world. And this is where a lot of us are discovering yeast technology. So how about I superimpose on that where our food technology is coming from? Because about 400,000 years ago, so our earliest evidence suggests in the Levant we're getting evidence of hominids using fire for preparing meat and being able to cook meat. Now I use hominids very specifically because it's not just Homo sapiens; it's Homo erectus. Neanderthals are using fire to cook meat. So it's not just a Homo sapiens or a human technology, but it's used for the hominid group of people, right? After that, we jump forward to roughly 10,000 BCE, or about between 10 to 12,000 years ago. Again, the scale of time that has passed between fire being used and us being able to use fermentation, right? This is where 10,000 years ago, between 12 to 10,000 years ago, is the first evidence of beer brewing and fermentation, right? That scale of time is inconceivable to me, because that 10,000 years could have happened 50 times over, 40 to 50 times over, from the use of fire to cook and preserve meat. And it's important to note that our evidence suggests that our ability to brew beer and to do fermentations predates agrarian cultures and the foundations of cities. So this is really a civilizing force, and we see this reflected in the culture from the Near East, right? We see bread and brewing being brought up in the context of epics from the period, in the religion from that period. In the Epic of Gilgamesh, Enkidu the wild man is only civilized after having sex with a prostitute. That's when he's introduced to civilization, but becomes a civilized member only after he's eaten bread and become drunk on beer. In the religion, there's a goddess in Assyria. There is a goddess of fermentation, Ninkasi, and we have a recipe for brewing beer that people have revived and are now brewing beer with now. Been told it's not very good, but that's neither here nor there. The fact is that fermentation is such a powerful technology that it has made its imprint in culture in roughly 2000 BCE, right? Move forward to the scientific age. Antony von Leeuwenhoek first observing yeast because of the physics, the advances made in physics and in optics. And who knows exactly what Leeuwenhoek was seeing under his microscope, but he's understanding that there are these tiny things in the food that are important for it to make this gas, make this foam on top of the beer. Right? I put in the Haber-Bosch process because it emphasizes how we've exited from an age of chemistry to an age of biology with the next landmark that I'm showing here, which is the ability to transform yeast, that is to introduce recombinant DNA into yeast. And why is that important? Well, shortly after we've developed this technology to introduce foreign DNA into yeast, we have companies that have moved away from producing insulin in pigs and going to the butcher to pick up pancreas and purifying insulin there, to taking the DNA, which is necessary for making the insulin, and putting it into yeast. Or they've also done it for E. coli, but the majority of the insulin that we're buying now is made in yeast. And you have this recombinant technology. that allows yeast to be producing these ecologically expensive, but very important proteins for human health, right? What else is going on? Well, a lot happened between 1978 and today, but perhaps the most important portion of this is that we are now in an age where we're thinking about reinventing our food structures yet again. 400,000 years ago, we talked about using fire to cook meat. And now we're on the verge of eliminating meat from our diets altogether. Now that's meant to be a provocative statement, and I apologize for having said that. But it's something to really think about, that this technology, this relatively new technology, 10,000 years in the grand scheme of things, is a blink of an eye. We have been able to revolutionize really within the past 50 years. And because of our ability to synthesize DNA, to sequence strains, we are now being able to hone this technology to develop all different sorts of meats and products for moving into the future, right? This is where I'm sort of ending this presentation. But I think the take home of this message is that food is relatively new, right? In terms of human evolution, preparation of methods of preparing food is there from the very beginning, before after Homo sapiens diversified. But our understanding of what food can be, our understanding of what constitutes something which is safe to eat, something which is easily prepared, something which preserves our food, and the technology associated with making food into a tool with which we can help save ourselves, help save the planet. This is all stuff which we're on the very edge and cusp of understanding and developing. And the future is a big place, and it's an exciting place to be in terms of biotechnology. I'll pause there, Mike. I'll stop sharing.
Great.
And,
can you
maybe now's a good time to get into some questions.
Yeah. Can you hear me okay? Sudeep, can you hear me? Looks like maybe you can refresh.
Oh, I think you may have frozen.
So this is, guys, we've had a little bit of these issues today. Sudeep will probably refresh here.
I'm going to try to refresh. Give me 1 second.
But one of the things, we'll just get you going here.
Sorry, I'm back.
Hey, it's okay. Well, it looks like we're just going to have to deal with this as we go. Can you hear me okay now?
Yeah, we're all set.
Great presentation. One of the things I will say is like you gave almost like a history of both food tech, but also I saw how intrinsically tied this very technical conversation is to culture. You're a scientist, but also it sounds like you're in part a culture historian. Is what you do looking at both of these things, are they inextractable from each other?
So I'm not. I'm married to an ancient historian, so that's sort of where we get off. So my husband, Paul Kosman, does ancient Greece, and we have these fantastic dinners with these wonderful historians of the Near East. So you really it's a wonderful opportunity for me to be thinking about what science and technology means in the context of in sort of like a broader cultural context. I mean, that's very generous of you to say.
Can you hear me still? Can you hear me okay?
Yeah, I think so. I think so.
Okay. As long as you can hear me.
Right.
So one of the things I went on Twitter today and I saw that the end of meat was trending. And I thought, hey, they're talking about our webinar. But then I realized they were talking about a New York Times article, but it was very timely. So thinking of that, and I read the article on the New York Times, and they talked about this future that's been ushered in a way through this pandemic. So when we think about lab-grown meat, can you hear me okay? I apologize, guys. I don't know what's going on with the platform today. All right. Can you hear me okay?
Yeah.
So this future where we're moving towards, lab-grown meat where fermentation is a key process, do you see a world where much of the space that we dedicate today to industrial meat production will move towards things like lab-based meat, fermentation, bioreactors, et cetera, in the future?
I think I got most of that question. And since I didn't, maybe I'll answer the question that I want you to ask, and hopefully we'll meet somewhere in the middle. So let's think about where food is going. And I think if I were to say that there will be no more meat in the next 10 years, 10 years from now, everyone's going to look at me and laugh, because as much as I would love for that to be a possibility, there's all sorts of things that we need to deal with in the next 10 years, right? And we can have a conversation about that. And I guess my answer to that is that my response, my ability to talk about that is the same as anyone else, right? Because that is part of the cultural thing that we need to deal with. In terms of technology, I think we're trying to do a lot of things when we're talking about meat replacements and thinking about replacing our industrial meat with proteins produced in microbes. I love yeast, but there's other microbes that are working for us here as well. So I talk about the Haber-Bosch process because Fritz Haber is thinking in the early 20th century, is thinking about how is he going to feed a population of people approaching 1 billion, right, with limited nitrogen sources, and the world is fighting over bat poop. These are the guano wars, or phosphate limitations. And what Fritz Haber does with chemistry is he's able to liquefy nitrogen out of thin air and make it into fixed nitrogen and make it into something which you can spray on top of your crops. And he saves the world from starvation. I'd be remiss if I didn't sort of point out that the Fritz Haber story takes a very dark turn, because he's also the person who's responsible for developing Cyclone A and Cyclone B, Cyclone A being used in the gas chambers in Nazi Germany. So it's complicated. To get back to the point at hand, what we try to do with these lab-grown meats is solve these ecological problems using the technology at hand. And we are now able to understand what protein looks like in animals, and we're getting a better understanding of what these proteins look like when we reconstitute them in microbes. And this is the first step in getting rid of industrial meat, but it's by no means the only step. And we have to have a conversation about culturally what role does meat play in our understanding of food, and what role does this new type of meat play in our understanding of food.
Great. Can you hear me still?
Gosh, I feel like I'm gonna
That's okay.
refresh one more time.
Guys, people are watching. We're having this issue, so he's going to continually have to refresh apparently. So as he comes back, I'll ask him a question.
I sort of like steamrolled you through. Maybe it's
okay.
I had something on the side.
No, you're fine. Can you hear me okay?
I can hear you, yeah.
So it sounds like maybe after every question, we have to refresh, but we'll keep going here. So, in our pre-conversation, we had a conversation before this, and you said something very interesting to me. You said the 20th century is all about chemistry, and the 21st century is all about biology. What did you mean by that? Yeah.
And sort of the precursor to that is the 19th century is all about physics and engineering. I talk about Newton and Galileo, and they lay down the framework for engineering processes, right? We have discussions about new processes, the steam engine being introduced, and really engineering solutions to our problems. in the 19th century, and then we get this wave of chemical solutions coming about. We have Dow Chemicals producing all of these things. We have petroleum petroleum byproducts being discovered in the 20th century, right? The Haber-Bosch process is the beginning, is the very beginning of an understanding of what chemistry can do. And again, this is going to be controversial, and I hope I don't get into too much trouble. What I think we're on the cusp of right now is thinking about how biology can solve all of our problems, right? We can now think about, Fritz Haber was thinking about nitrogen fixation as a chemical process, and an incredible amount of human energy is made to is being used to fix nitrogen, and we can now think about that process differently. We can think about how can we engineer bacteria that are found in the root nodules of these plants to be able to fix nitrogen again, or even more, right? We have these companies, Air Protein, for instance, that is thinking about fixing carbon, right? You have carbon dioxide in the air. How do you get microbes to gain access to that carbon dioxide and fix that? And how do you engineer those microbes to fix that carbon dioxide into food and into protein? Gosh, I apologize. We've frozen once again. I'm going to refresh, and maybe we can move on to question number 2. I really am sorry.
That's okay. So I think I will talk to Sudeep about maybe putting the questions in the chat channel. I'm also going to maybe bring Catherine Lamb on screen, and maybe between the two of us, he could see one of us consistently. So can you see me, Sudeep?
I can see you. I can't see Catherine just yet.
I haven't brought her on yet, but I will. Let me ask you next question, and then I'll see if I can bring her on. But also, like, we might just also revert to the chat channel for asking questions. So,
sure.
But one of the things, we've written a report recently in Spoon Plus about this topic of gas fermentation. You talked a little bit about the idea a little bit in your pre-chat, in your presentation. It seems like this old technology that was developed in many ways during the space race between the Soviet Union and the U.S. This idea of fermenting, taking CO2 and producing protein, has gotten a lot of recent traction, and it is a way to maybe create protein that doesn't tax the earth as much. Is fermentation basically a platform through which we can maybe feed 9 or 10 billion people much more efficiently, if we could scale it? And is air fermentation, air protein, one of those ways in which we can do that?
Yeah, really good question, and the hope is yes. So listen, we have a lot of challenges coming to us in the 21st century, right? I hope this isn't a controversial statement, but we are now thinking about how to feed 10 billion plus people, which is an inconceivable number of people right now, right? In a defined amount of time, we will be seeing those numbers, which requires a lot of food. We have dwindling ecological resources, which is why we see this thing, the end of meat is today, and how that's. Hi, Catherine. Sorry, we have this understanding of the end of meat is today, and really understanding the ecological cost of food and how that relates to the economical price that we're paying for the food, and how those two things are really in disparity. So this ability to produce food out of thin air, like Fritz Haber was thinking about, is such an attractive way of being, and such an attractive thing to think about, right? What if we didn't have to have carbon in the form of sugar? What if we could just feed carbon directly into our fermentations, right? Hi, Catherine. Lovely to see you. I'm afraid Mike's frozen on me again.
Can you see me?
I can see you just fine.
Well, great to see you again. Welcome to my living room. I have 2 questions for you. So I don't know, maybe I'll start with the first because it's a little bit more related to what we've been talking about with the meat alternatives. So obviously you were talking about, you guys work at Ginkgo Bioworks and Motif Foodworks, making these sort of next-gen solutions to help companies make better animal alternatives, be it meat, be it milk, yogurt, etc. I wonder how you envision the distribution of new protein sources in the future, especially since you have this cultural interest. Do you foresee it being a mixture of meat, traditional meat, plant-based meat, cell-based meat, etc., or maybe just all alternative products?
Sorry, would somebody mind just typing the end bit of that question? The distribution of goodness, I'm going to try refreshing one last time.
Yes, there's
really
a question too in the question chat. Put it inside.
Yep.
Oh, sorry, much easier.
That's okay. I just typed it over in the little side section as well, if that helps.
Really, yeah, I really appreciate that. Thank you. If I drop out, I really appreciate that. And please stop me if I'm going on too long in the sidebar. I appreciate that. So yeah, how do we think about how do you envision the future of meat? Will it be plant-based, cell-based, a mixture? So I think basically, not to detract from what we're saying. Right now, we're not producing meat in our fermentation. What we're doing is we're producing flavorants that imitate meat. So we are able to find proteins that bind to heme cofactors, and that these proteins are, when they hit heat, they release the fragrances and smells of meat. There are companies out there that are actually putting in a lot of thought on how to do that. And there's this, in preparation for this, I've been reading this, I read this really lovely book by Ben Vergast, Meat Planet. I'll put the link in right now.
Yeah.
What Ben did was he's been following the meat, the meatless meat program, and really thinking about the cultural aspects of what meat is, and the future of meat, right? And there's a lot to unpack there, right? Will it be cell-based? There are people working on making cultured meat, bona fide cultured meat, where you get meat cells growing on top of each other. Right now, you will pay a few years' income in order to get one of those hamburgers. But there are alternatives, right? You can take plant-based proteins and supplement them with these meat flavorants that we are finding in the microbial world and are being able to reproduce in the microbial world. What that means for us and how we think about that is interesting. And the emphasis that we put on meat versus different protein sources, you mentioned yogurt or other types of dairy products, is also interesting and really says a lot about who's paying for this research, what culture we're trying to support with our development of these tools. And like the world needs protein, and we will have 10 billion people who need protein. And maybe meat is the entryway to something much more bigger and much more resilient to the needs of the planet. I should apologize. I'm afraid everyone's frozen again. I'm going to refresh, and I'll see you guys in 2 seconds.
That's okay. Catherine, can you see me?
Yeah, you look good.
Okay.
Can I ask another question?
Yeah, go for it. You have the next question.
Yes.
As he comes back.
This one's a little bit more. So I've chatted with Sudeep once before. We were talking about sourdough, which, we're all baking right now, or have tried to bake. And I know this is going to veer a little bit into your cultural anthropology knowledge, Sudeep. And I put the question in the chat for you.
Right.
Basically, in your timeline, you were showing about how bread or fermentation, bread, beer, etc., has really shaped culture through human consumption and a new technology that's had a large impact in us as humans. And I'm wondering, we seem to be at sort of an inflection point. We had fermentation to make beer, to make bread. We've had that for thousands of years. Now we're using fermentation in such a futuristic way. It seems like we're switching it to really manipulate these yeasts and other microbes. How do you foresee that sort of new fermentation shaping our culture going forward?
Yeah, really, really cool question. So I think so I'm going to answer that in two parts. One is, listen, COVID has been a disaster. But one of the things which on a personal level, I'm really pleased to see is that people are rediscovering the microbial world around them. That there are beautiful microbial communities just lurking in your kitchen cupboards. You take a few grapes, or you take a few raisins, and you pop them into flour with some water, and you get the next morning you come down and you see this thing overflowing on your kitchen counter, and that's yeast, and that's what I deal with. And that's what I think about. I know this is not a global phenomenon. There's like a small niche. I've stumbled onto sourdough Twitter somehow, but sourdough Twitter is a beautiful place. And why I think that's really exciting is because people are now thinking about microbial communities and how to engineer microbial communities and what the possibilities of these microbial communities are in a way that maybe they wouldn't have been thinking about had they not been seeing these microbes sort of like literally spring to life in front of your eyes overnight, right? So I think that's one part of culture, that we have basically rediscovered the 18th century, and understanding and realizing that there's microbes in our food, and all the things that they can do for us, right? And I wonder if that's what's going to happen with thinking about the culture moving forward, right? Because now that we know that there's microbes all over us, and that if we have a culture in a jar in front of us, and we change components of the culture, we are providing a sort of natural selection of that. So if we change the temperature of the water slightly, we get a different type of yeast springing. If we change our flour from wheat flour to white flour, we get a different form of flour popping up, right? And I think that's really an interesting thing thing that clicks in your mind, because yeast is technology, and maybe now that we're seeing this technology brewing on our counters, it is going to be more comfortable for us to think about what other things can this technology do for us, right? So it's this democratization, or this broadening of this field that I'm sort of sitting in and thinking about on a regular basis, and I wonder if that's sort of the beginning of something interesting moving forward, right? Happy to clarify on that. I may have missed the point of the conversation. Let me refresh.
I think that was a pretty good answer.
Yeah, I'll ask him the next one, and we'll just have to kind of back and forth. Also, people, if you have questions, feel free to drop them in the sidebar and ask in the questions. There's a few questions people ask. Hey, Sudeep, can you hear me okay?
Yeah,
so I want to ask you, one of the things that we had people ask in the registration form, there's space for question, is like, how can we get to scale and get towards mass fermentation? One of the things I think as we move forward is we're just going to have to do this at a much faster pace, at a much bigger level. Also, I have a kind of related question, because I've learned a little bit about this in the past, and there's been a few companies thinking about bioreactors for the home, and you basically talk about a mini bioreactor with creating yeast. But the second part of that question is, do you think that consumers will have, at some point 10 years from now, some form of bioreactor in their home?
Yeah, so I love this image of your sourdough culture being a mini bioreactor at home. And let it also be said, like people already have these bioreactors in home. Like there are a lot of people, who are brewing their own beer at home, and that is essentially a bioreactor. And the technology that we have today to produce these beautiful proteins in yeast, or to produce other small molecules in yeast, that the crux of that has been the beer brewing industry. We now know how to control yeast using sugars and different components. I'm just seeing a message on the side saying that everyone's frozen. Is that true for everyone?
I think everyone looks fine to me. Sudeep, can you hear me?
Good.
Okay. Keep going.
Anyway, so people. What I like about the question that you asked, Mike, is Is a sourdough culture a bioreactor? No, not really. I mean, it probably is. It probably is. It's just a different medium than what we think about in terms of bioreactor. But people have been dealing with these bioreactors in their basements and in their garages for a really long time. And what I love the image that you post of, now you'll be able to go to the grocery store and pick up a strain that you can basically pitch into a glucose solution or a maltose solution or a grain solution and be growing your own different flavorants. Now, again, as a technology, that sounds absolutely incredible. Like produce your own specific type of protein, your own favorite protein, and that's that's a dream for the future. Before that, however, of course, we do have a conversation about GMOs and what GMOs mean for us culturally, right, in a cultural context.
He's refreshing. He's just doing it automatically. I'm not quite sure. Last one, maybe Martin has a question. Hey, can you see us? Hear us?
I can see it. Yeah.
Well, I want to ask you this because you said you stumbled onto sourdough Twitter, and that was kind of the reason you came into our universe. There was a great thread you had. Catherine wrote about it during the great yeast shortage of 2020.
Still in it.
Yeah. So a couple questions there. What was it like becoming part of the Twitter famous for a while? That's just kind of a fun question. But also, as yeast becomes part of the zeitgeist and part of the conversation, is this an opportunity for a broader conversation, right? Are you excited about this? And it seems like you've kind of been nibbling around that answer a little bit, but I'd just be interested to hear that. So. Yeah,
I was so pleased to ask that. So thoroughly enjoyed my full 15 minutes of fame. So glad to be back in the real world where no one really cares about what I tweet.
We care.
No. The best part about that is seeing all these people who you never really come across. Really sort of reach out and share recipes, and I get all these beautiful pictures of bread. That's been a lot of fun, and even being able to swap recipes, it's been great. But the second part of your question, right, of catalyzing a larger conversation about what biology means to us. So I have a few threads. One of the things that people have been thinking about is terraforming Mars. And I know that's a scary thing to bring up, but I have this friend, and Mike, I talked to you about Shannon Nangle, who's at the White Institute. And I'm sending along two links there. One about sort of Shannon and her work there, and sort of this white paper that they put out at the very beginning of the COVID crisis. Which was unfortunately timed, but is a really fascinating thing, because once you think about microbes, once you think about bioengineering, you can think about all different types of applications. And as a thought exercise, you can think about, in the same way that people are racing to the moon and developing technologies for the moon, now that we're in this world of engineering biology, how can we take what tools can we develop in preparation for terraforming Mars? And then not do that, right? Let's think about terraforming Mars. Let's develop all this technology, and then actually have that technology to save our planet, or actually have that technology to think about more creative ways of cooking and producing food and protein for our population and for our planet. And that's what I really love about Shannon's work and Shannon's research. And what I hope, sourdough Twitter. So in my dream of dreams, this is phase 1 of Sudeep introduces the world to microbes, and stage 2 is let's talk about engineering, and let's talk about food and where that can take us. And that's just stage 2 of my dastardly plan to make the world fall in love with yeast genetics. And then if there's time, we'll talk about bacteria. But first we'll talk about yeast genetics.
So there's a conspiracy theory as part of your grand plan. Can you? Oh, he's refreshing. I have a question for Mia. I'll ask him when he comes back momentarily. Mia Walgast.
Sounds good.
If he doesn't.
I got
hey,
one
Sudeep. Hey, Sudeep, how are you?
Yeah.
So I'm going to put this question in the sidebar, and I'll ask at the same time.
Sure.
From Mia Walgas, she says, "Can you discuss what you know about other applications of fermentation, such as algae as a source of protein, for example?"
Yeah, exactly. So we've been talking about sort of yeast and a yeast-centric view, and there's a very good reason for that, because yeast we've been dealing with yeast for at least 10,000 years, or we now know we've been dealing with yeast for roughly 10,000 years. We have it embedded in our culture. We have it embedded in world religions, right? But the truth of the matter is that I'm biased because I love yeast and I love yeast genetics, but the rest of the world is in love with different types of bacteria, algae, for instance. And it's not just meat and not just protein. We can think about other small molecules. So when you have a lovely leg of lamb in front of you, you are not having just the protein from the leg of lamb. You're having different fats that are giving it different flavors. You have different types of compounds that are sort of giving you different textures in your food, and yeast can produce a lot of those. But there's an entire world of organisms out there that can do that for us. So we can think about producing different types of fats in algae, for instance. Algae are very good at producing different fats. Different bacteria give us these different sort of textures. If you think about a kombucha starter, right? There you have this SCOBY, this mother that sits on top, and that's all sugars that have been stitched together by bacteria. And thinking about these different texturants and these different foods, that's all coming from an entire microbial world, which is again sitting in your kitchen cupboard, and it's a matter of being able to harvest it. And I think this is the other thing about being part of biotechnology today, namely that biotechnology is not it's not that biotechnology is engineering a single organism, as it has been for the past 50, 60, 70 years, however you think, right? So the world that we're living in now, and I'm gonna talk about Ginkgo because I really do enjoy my work at Ginkgo. The lovely part about being at Ginkgo is that we are now able to take a sourdough starter or a kombucha starter or take a soil sample, and we are able to identify each different organism which is living in that soil sample, sourdough culture, kombucha culture, and we're able to isolate them and we're able to characterize them. And now, I'm answering your question. Just wait for it, because once we're able to categorize them and identify them and store those different organisms, we also have the technology and the ability to engineer those different organisms. So you tell me that you need this flavor from a plant which is going extinct, but it's the favorite component in your perfume, or even as Ginkgo has shown, right? Plants which have gone extinct, roses which have gone extinct. We're able to look at their genomes. We're able to identify the snippets of DNA that gave those roses their fragrance. And we're able to put them into your favorite organism to reproduce those fragrances yet again. The reason microbes are lovely is because of this question about bioreactors. Microbes don't need the sun and the right air conditions. They need a large vat of sugar and precisely controlled oxygen situations in order to produce these other compounds. And that's a really powerful tool that we've been able to play around with.
Can you hear us?
Also, I see that Christine is saying hi. Hi, Christine.
Yes.
Lovely to talk with you. I'm going to refresh because everyone's frozen on me again. I apologize.
I have a question, Mike, unless you have one.
Go for it.
All right, I'm going to post it on the little side.
Hi.
Hi. Can you hear us?
I can hear you.
Okay, cool. I have a question for you, and it's piggybacking off of Mike's previous question relating to your fame on Twitter, where you noted that sourdough is obviously having a moment right now. Everyone's trying to bake it, cook it. People are getting more familiar with yeast, possibly than ever, at least in my memory. So do you think that as consumers become more familiar with and enamored with yeast from within their own home, that they'll be more open-minded towards these new fermented food sources that you guys are making at Ginkgo, or Impossible is doing with their heme. I'm talking plant-based meat, I'm talking flavorings, etc. And the question's in the sidebar in case.
Yeah, no, I got that. And I think that's definitely the hope. And I can answer that in like multiple stages, right? Like, I think the first stage is there's a microbial world around you. There's a not to get too graphic, but there's a microbial world inside of you. We are finding ways of manipulating the microbial world inside of you. I believe the 2006 Nobel Prize was for being able to show that you could solve stomach ulcers by taking an antibiotic, right? Suggesting that there's a bacterial infection which is causing these ulcers, right? So like understanding the microbial world around you, especially in a COVID world where you're seeing this invisible particle wreak havoc in the world. Like that's interesting, but to also understand that there are other invisible particles that are causing you to have food on your table is the first step. And I wonder if in 10 years' time, right, as our understanding of the microbial world grows, as our understanding of what microbes can do for us improves, that we won't have a more clear understanding, and that these ideas that we play around with now about it's GMO, is it safe, or do we want proteins from these microbes, that we can have a much more informed conversation about that, because people are thinking about microbes in a much more meaningful way. The part where I want to veer off the food chain is to think about what else can microbes do for us, because microbes aren't there. We've discovered microbes for food. We've in stuff that I haven't had a chance to talk about. We've used microbes to model human disease, right? And that's an entirely broad. That's an entire field in itself, and like that's where I first fell in love with yeast. But like the question is, what can microbes do for us next, right? Can we use microbes to solve our ecological crisis? Can we use microbes in oil spills? Can we use microbes to help to make construction materials that are more ecologically friendly? And that's a really compelling way forward, right? And not just solving the big questions, right? Like what role does microbes have? Do microbes have in fashion, or what role do microbes have in art? And revisiting what role how does microbiology contribute to our culture, and how has it been contributing to our culture?
Can you hear us? Oh, he's going to refresh. I'll ask the next one. It's from Chris Finn, and I put it in the sidebar. When Sudeep back. Hey, no problem. I think we're used to it by now. Sudeep, there's a question from Chris Finn. I put it in the sidebar now.
Oh, yeah.
Can you discuss the potential opportunity to engage CNS disease via fermentation and digestion in the GI tract? Is that something you think you can answer?
Oh gosh, no, I don't think so. But like, watch me try.
Why not?
Yeah. So, listen, like one of the really interesting things that we've discovered is how the microbes that live inside of us in our gut really play a role in autoimmune disease. Really play a role in our moods, and how it really affects our central nervous system. These companies, Synlogic, for instance, is finding ways to engineer microbes that live inside of us and help resolve a lot of the digestive issues that people are having. Once we've been able to engineer microorganisms to help resolve these diseases, these sort of like digestive diseases, you can really think about how microbes can be used to solve neurological diseases. And as we get a better understanding of the interaction of the microbiome with human biology, right, and what molecules the microbiome is producing to impinge on human biology, we can start resolving these things. And this sounds like science fiction, but like, if I told you that we'd be eating plant-based burgers that actually seem to bleed blood 5 years ago, you would have called that science fiction too, right? I don't want to say that it's going to happen tomorrow, but I think we have a good road forward to understanding how that happens and thinking about solving something like that in the next 10 years, right? Yeah, the future is closer than you think it is.
Can you hear us still? So you can hit refresh. I'll ask a question from Michael Height when he comes back. And Catherine, if you have one after that, feel free.
Yeah. Got a pretty futuristic one.
So hey, Sudeep, you yourself said you're used to being in sourdough Twitter at this point. So this question from Michael Height is, which I'll put in the sidebar now. Let's see here, which I think you could probably answer. He says, I think it might be a fun one, and also kind of ties into this bread question. So can you briefly chat about the difference in structure and results from making a sourdough with AP flour, I think whole wheat flour, flour, and correlating bread flour types?
Yeah. First of all, hi Michael. We've been chatting back and forth on Twitter. So and this is where all the professional flour bakers are going to like reach into their hair and start ripping it out because a yeast geneticist has started to talk flour. And I apologize for that. But one thing to take a look at is when you have your bag of white flour, it's never just ground up wheat in there. And you're going to see, if you read the side of that, you're going to see all different types of flour in just a bag of white flour. And what are those other, like most usually you'll see a tiny bit of barley flour in there. And sometimes you'll see soy flour in there and other sorts of additives. What are those doing? Well, depending on what's in there, those different types of flours are adding different types of proteins to your white flour. Sometimes those proteins are going to give you a very clean white loaf, which is in maybe I'm a proud East Coast elite, but like I don't like white flour, or I know I should like white flour, in other cultures, right? Like people really want to have this very clean white texture. So these additional proteins are helping to bleach it. Other proteins are there to help release sugars from your flour. So starch is basically a long chain of sugars, right? And there are proteins called amylases that can come along and chew up those long chains. And the yeast can then have access to that. So when you're making your sourdough, you have this stage called the autolyse, where you have your flour and your water and you mix them together and you just let it sit. That hydrates these proteins and allows them to act on your flour, right? And allow them to start releasing sugars and start bleaching or letting the flour come alive. And then you add your leaven, and the leaven can start eating all these different sugars. This is just talking about all-purpose flour. In terms of whole wheat flour, you have the difference between all-purpose and whole wheat flour is the amount of extraction, right? So all-purpose flour is a very low extraction. You take a grain and you get a tiny bit of flour out of that because it's all due to the granularity of how fine a grain you are. Whole wheat has a lot more of that germ in there, and that germ has additional nutrients in it. So if you have a sourdough starter that you're doing with all-purpose flours, it's a very nutrient-poor medium for you to be having your sourdough starter in. I like it because you have a very stable source of flour for everything to be for your yeast to be growing on, and you don't get much drift. If you want a lot of drift, I encourage you to start using this whole wheat media, and you're going to get all different types of things popping up. Drives me absolutely nuts, which is why I keep my starter in all-purpose flour. I also realized that I've taken a full 5 minutes on this, so I'm going to stop talking because this is an hour-long seminar in itself. But yeah, super interesting stuff. Really, really interesting stuff.
And if he might refresh, yep. And I'm going to intro that question from Adam. Thanks for putting that in there, Catherine, because I want to introduce. Well, I'm just going to.
Yes.
Hey, so Catherine put a question in from Adam Yee, we're just having you as like a baking consultant at this point. So
Happy to be.
I want to introduce a question from Adam E, who also I think is maybe semi coworker now. He's at Motif.
Motif.
Motif, and he also is the guy behind the My Job Rocks podcast. Hi, Adam. Thank you for listening in. But you'll get to, I hope you get to know Adam. He's a great guy. And he asked, in case I run out of flour again, can I use a different or better feed?
Yeah. So what happens when you run out of flour? And this is, I'm going to get on my soapbox and I'm going to end all this on a hot take, and don't at me on Twitter, right? The world, why are we all turning to sourdough starter right now? And listen, I think that's a fascinating question, because I don't know the politics of this crowd, but I'm obviously an Indian man growing up in Boston, Massachusetts, and like one of the things that we've been talking about for the past really intensely for the past 4 years is having this multicultural global society. So when I was growing up, I remember not being able to find lentils at the grocery store, and then all of a sudden in the mid '90s. You get these grocery stores start stocking lentils, and like all of a sudden, these foods that my parents love and have told me about, they're able to prepare at home. And you get this even more. When I was growing up, you couldn't find brie cheese. Brie cheese was something that you have to have imported from France. But now everyone has a wheel of brie in their fridge, or orchids sitting on their counters at home, and that's great. Like, don't get me wrong, I'm not gonna argue with that. But and here, whatever, I'm going to get myself into trouble. The moment something goes wrong, everyone scurries back to their white bread, and everyone says, "I want to bake a loaf of sourdough bread." And let me tell you, that is a fiction. That is a fiction because you are nervous and you are tired and you're scared, maybe, right? And like, just look around at this beautiful multicultural world that you've developed, because we have lentil flours and we have different types of grains. It's not just wheat out there. We have rice. We have different pulses that you have around that you're able to ferment. One of my favorite foods is called dhokla, which takes chickpea flour or gram flour, and is a fermentation based on the chickpea with yogurt, but I've made it without yogurt as well. You take chickpea; it's a source of carbs. It has protein in there too. You get a different texture, but you can make these lovely cakes with chickpea. You can go to injera, right, and look at teff flour in sort of African cultures. All of East Asia is obsessed with different types of fermentation, and all of these things you can have bubbling away on your counter as you while away the hours in lockdown, keeping a safe social distance from all of your colleagues and loved ones. Sorry, I think Ariella has an interesting question, but I'll let anyone else follow.
That was a good hot take.
That was a good hot take. I like the hot takes, and I like how passionate Sudeep gets. And we'll make Ariella as the last question. We'll make Ariel as the last question, and then after you answer, you may have to refresh so you can say goodbye. But she asked, "Why are we in love with sourdough?" It's the question at the core of humanity. Is that the question? Is that the question you thought was interesting?
You cut me deep, Ariella. You cut me deep, because it's not just sourdough, right? Like I guarantee you that the majority of the world has not heard of sourdough, and I think even thinking about Europe, right? Let's talk about Europe. Europe is sort of neatly divided into beer drinking Europe and wine drinking Europe. And let's talk about bread in South Asia, in India, right? Like bread, even India is divided into into wheat India and rice India, right? And there's interchange there, right? I grew up on sort of a diet of fermented lentils, which become nice and puffy. So we think about the Near East and the origins of fermentation in the Near East, and we think like, yes, the world is in love with sourdough, but that's the archaeological evidence that we currently have. And if we go a bit broader if we step out of our doorstep, we can see there's a wide world of fermentation. And while we're stuck at home, that's sort of the place to get started. I'm going to refresh. I apologize for all the technical issues. I'm going to refresh. I'll be right back.
I think it's fine. Well, I think everyone, we're going to say goodbye to Sudeep and thank him. This has been a lot of fun. Catherine, thanks for being a hero and coming on without even knowing you're going to be on camera today. I appreciate it. Sudeep, that was the last question. I want to thank you. I want to thank Catherine for being a hero, coming on and helping out.
Yes.
She brought us together, and thank you so much for doing this. And everyone, as we say goodbye to Sudeep, we'll send out all his links that he put in the sidebar in a follow-up email. Sudeep, thank you for doing this. And everyone, please say thank you to Sudeep for spending time with us. And that's the end of our call today. Thank you, everyone.
Thanks, everyone. Really appreciate it.
Bye, everyone. This is great. Have a good one.